Alright, Electric Motor Division General Motors Corporation Maintenance Instruction 549 Revision A Water Cooling Radiators. Introduction. Heat from the engine cooling system water is dissipated through the means of the radiator fan arrangement. Heat development of the engine transfer of the water into the radiator directly with the engine within the radiator water into the tubes called the core. Figure 1, using tube material with the conductor of the fan draw the ambient air between the tools of the cooling with the heated water. Fins attached to the tubes aids with the cooling of the valve with more air to contact with the heated tube surface of the maintenance instructions describe the procedures necessary with the cleaning and the repair of the radiator. Cleaning. When it becomes necessary to clean the radiator, the following procedures. 1. Mark areas of the SI with the core with the show of the sign with the water treatment, the color with the discolor with the areas indicate with the leaks will help to be repaired through the remove the header if used. 3. Straighten bent header flanges, comb bent vents to ensure the airflow is not reduced. 4. Blow the debris from the fins, compressed air with the clean gasket surfaces. Figure 1 shows typical radiators. 6. Fill soak with the undiluted non-toxic organic cleaners. Serve the data level should be sufficient to allow the complete submersion of the radiator. 2. Caution. Use caustic cleaners and not recommended with the bonding side of the deteriorate within using caustic cleaners causing leaks and hindering heat transfer. Soak radiator core for 3 hours and still with the tank with the tubes low lying. Alright, caution. Use caustic cleaners but not recommended. Bonding solder with the deteriorate with using caustic cleaners causing leaks hindering heat transfer. 7. Soak with the radiator core for 3 hours, still with the tank with the tubes lying horizontally. Cleaning solutions agitated to cut soaking time in half. Note, cleaning is more effective with the agitated tank. 8. Rinse core using steam water. Make sure rinse core as soon as possible to prevent residue from hardening. Radiator core testing. Radiator core's failures other than damage can be categorized in 3 headings. Fit to tube, the bond failures. Fit to tube, bond failures. Tube failures, tube to header for bond failures. Repair limits for the flying the tube, fin to tube bond, and tube failures are specified in surface data. If the failure is within repair limits of the core can be repaired. If not, repair is not feasible, but the core should be scrapped. Fin tube bond check. Loose fins will hinder heat transfer or allow the tube to expand with the water pressure of the expansion contraction cycle will eventually result in the tube fracturing using following step of the check the fin tube bond. 1. Use suitable tool or probe. Check the fin tube bond by gently pressing against the fin collar. The loose fin will move relatively to the tube. It supports figure 2. 2. Repeat steps 1 for each fin. Measure the loose fin area of the radiator should be scrapped if the loose fin area exceeds the limit specified under surface data. Figure 2 shows checking the fin to tube bond. Note, if the loose fin is more than 1 inch of the tube length unsupportive of the tube should be removed from the surface and receive the tube repair. Leak test. Tube leaks and tube header bonds. Leaks can be accurately located in the following procedures. Install sealing plate with a tank with each holder flange of the core. Apply 50 psi air pressure on the tube side of the core immersed in clean water at room temperature. Caution, avoid exceeding 50 psi pressure. High pressure may damage core tubes. 3. Mark tubes areas of the tube to header bonds and emitting bubbles. 4. Qualify core by using repair limited information given in the surface data of the core should be scrapped and the tube's failure to exceed repair limits. 5. For repair procedures, refer to either tube repair, tube header, bond, or repair section, depending on the nature of extent. Tube repair, tube leaks, repair sealing each end of the defective tube with solder, eliminating it from the surface of which when loose fins that leave more than 1 inch of the tube unsupported should be sealed using method experience shown in that has a 2% total tubes that can be sealed used by this method without adversely affecting the efficiency. Using information given under surface data with a guideline determining whether the core is scrapped or repaired. Use this procedure both solder mechanical tube to header type bond. Solder tubes could be using the following procedure. Note, recommended heating, typically melting out old solder and applying new solder is listed in surface data. Thoroughly dry the inside of the tubes to be repaired. 2. Pinch one end of the tube to be repaired closed. Note, use brass plugs to close tubes on mechanical tube to header type bond cores. 3. Clean tube with zinc chloride flux. See with the surface of the depth of the applying flux play with the medium flame flux. Surface of the heating with the boil of the flux. Improvising cleaning ability with the surface of the wire brush. Scrub and clean area with which area are being prepared for solder. 4. When the tube is thoroughly clean, solder pinch plugged in with 50% tin, 50% lead soft solder, and a 470 degrees flame for surface data. 5. Flush each solder tube to avoid trapping unused flux inside. Thoroughly dry inside of the tube. Tube core solder opposite end of the tube as described above. 8. Clean flush both headers with the water. 9. Repeat leak test to ensure that all leaks have been eliminated. 10. Spray all external surfaces with one coat with a black radiator paint. Surface data. Avoid spraying gasket, water, swept surfaces. Note, mix equal parts of radiator paint with a UPM naphthol. Tube to header bond repair. Majority of the tube to header bond leaks occur in outer two tube rows alongside of the header, although less common leaks at the middle of the tube rows are also possible. Note the procedure intended to be used only solder bond type of the radiator cores which have the mechanical tube to header bonds are not repairable to be using this method. Repair procedures are similar to both outer and middle of tube rows, the primary difference being of the area which for the older solder is melted with the repair of the outer tube that require the solder removal from one of the two outer tubes rows on each side of the core. A total of 4 tube rows. Metal tube rows failures require the entire area of the solder in the header to be being melted. Header be melted out. Recommended heating tip for melting out old solder and applying new solder is listed in their surface data. While repair tube header bond failures is critical to the header and to keep in position which is a square of the tube with the cock header. A cocked header will cause the load on the top header of bond, causing premature failure when removing. Outer tube non-failure for the header with a held screw with a solder with does not remove the middle tube rows to the repair the middle tube row failure of the clamping the fixture. Figure 3 should be constructed to hold the header square where the repairs are made. Alright, shows the D length, the top and bottom angle, H's and G's and F's at center. H's and G's on the outside, 5/16 of an inch diameter, 7 holes at the bottom angle, 19-inch welded area, 4 holders, bottom end, tack weld all 4 edges, half inches, angle, 90-degree angles, dimension chart, 8-row core, 6-row core, 6-row double length, single length, dimension chart for A, B, C, D, and E, and F, and H. Outer tube row repair. Leak detected within the first 2 outer tube rows may be repaired using the following procedure with the core retesting both header and flange of the tube with a horizontal position. Melt the solder first 2 outer tube rows nearest the surface of the core. Rest on the cross hatching figure 4 indicate the area within which the solder is to be removed. The melt the solder out by playing a 620 degrees flame over the area. The melted solder will run out of the dish over the head flange and out. Turn the core over so that the 2 unmelted rows which were atop are now nearest the surface of the core as you retesting on repeat steps A. Clean all surfaces of the header to be resoldered with zinc chloride flux surface data using a syringe to ensure all the cracks, tubes, and header surfaces have been cleaned with flux. Note when applying flux to a medium flame, fixed flux surfaces of the heating will boil with the flux and improve the cleaning and ability of the softer wire brush to scrub, cleaning the areas which are being prepared for the resoldering. D. Repeat step C's using clean flux. This will remove any remaining dirty flux, to which core was resting on the one header of the tubes in the vertical position. Run length of the number 7, 1/8 of an inch diameter silver water solder along each tube row. Surface data using 620 degrees flame to sweat the solder into the tube header joint. See figure 5. Figure 5 shows the radiator core cross section, a header, your puddle solder tube, and silver solder tube to header joint and fin. Figure 4 shows the radiator core schematic and a header flange and tubes. When solder stops running, using a small amount of flux or wire brush, cleaning an area of the reapply solder from the gap between the header and first tube row using a 3/8 inch tri-bar puddle solder. See servo the data at 500 degrees flame. Build up the puddle with a minimum depth of 5/32 of an inch. Blend the increase the depth up to 1¼ inch edge of the header dish. Solder spacing between the rows at 1/8 inch wire puddle solder for surface data at 500 degree flame. Blend excess solder 500 degree flame carefully so that it runs out of level outs, and make certain that the old and new puddle solder is well blended. 5. Remove all traces of flux by immersing core several times in cold water. 3. Repeat leak tests to ensure leaks have been eliminated. 4. Spray all external surface with 1 coat of black radiator paint. See surface data. Avoid spraying gasket, water swept surfaces. Note mix equal parts radiator paint and UPM naphtha. Middle tube row repair. Use the following procedure. Repair leaks in the middle tube rows. 1. Construct a clamping fixture using the dimensions shown in Figure 3. Note that the clamping fixture will keep the header square while core is being repaired. 2. Bolt each half of the clipping fixture with the core header flanges. 3. With the core resting on both the header flanges of the tube's horizontal position. A. Melt out all solder from the tube to header bond. Melt solder by playing a 620 degrees flame over the entire area of the soldered metal solder run out of the dish over the header flange and out. B. When all the solder has been removed, clean all surfaces that are resoldered with a zinc chloride flux. C. Surface data. Use a syringe to ensure all cracks and tubes and header surface have been cleaned with flux. Note, when applying flux, play a medium flame of flux surface. If the heating will boil the flux, improving its cleaning ability, using soft wire to scrub the cleaning area while being prepared for resoldering. C. Repeat steps using cleaning flux. This will remove any remaining dirt flux. Perform steps 2 through 4 under the outer tube row repair. Surface data specification: fin to use tight tube bond, loose fin to tube bond, total area not to exceed 15 square inches. Loose fin to tube bond, no single area to exceed 10 square inches. Tube repair: maximum number of adjacent tubes required. 4. Maximum percentage of total number of tubes repaired, 2%. Equipment solder soft with a 50% tin, 50% soft tin, 50% tin, lead, 1.5 pound bar. Black paint radiator: use 1 part paint with 1 part UPM naphtha at 1 gallon can. Solver tri-bar: 40% tin, 60% lead, 25 pound bar. Solder silver: 2.5% tin, 97% lead, 0.5% silver at 1/8 of an inch diameter on a 25 foot-pound spool. Solder puddle: 38% tin, 62% lead, 1/8 of an inch diameter, 25 pound spool. Flux zinc chloride, 1 gallon can. Cleaning solution: Quaker solvent cleaner 72, Celsiolone or octite number 31. Soldering tip stainless steel tube available from National Cylinder Gas Blower Pipe Company under PN number 727 and 813N. Alright, that was Electric Motor Division, General Motors Corporation, Maintenance Instruction, Water Cooling Radiator, Maintenance Instruction 549, Revision A.